Let's look at how we can graph the solution to a system of inequalities. So here we have a system of two inequalities. These are both linear inequalities. So on our graph we're going to see two lines, and then we're going to shade the region of our solutions. So let's look at our first inequality. 3x minus 2y is less than or equal to 6. So I'm going to think about this one first and look at solving for y, so getting y on one side by itself. So I'm going to go ahead and subtract 3x from both sides. So I have negative 2y is less than or equal to negative 3x plus 6. And then I'm going to divide by negative 2. So remember, with any inequality, if you divide by a negative, it's going to flip the direction of our inequality. So this is going to become y is greater than or equal to positive 3 halves x minus 3. So when we're putting this on our graph, this is going to be a line. This line has a slope of positive 3 halves, so it goes up 3 and right 2, up 3 and right 2, and it has a y-intercept or a vertical intercept at the point 0, negative 3. If you look at the type of inequality we have, it's a greater than or equal to. Because it has the option of being equal, when we graph this line, it's going to be a solid line. So it's similar to the idea of an open circle versus a closed circle. We'll use either dashed lines or solid lines in the same way that we used open circles and closed circles. So let's put this on our graph first. So I'm going to start at the point 0, negative 3, and move up 3 and right 2, up 3 and right 2. And then I'm going to connect my points with a solid line going all the way across my graph. So while we have just one line on our graph, I'm going to go ahead and determine which side of the line is going to have the shading. So there's a couple ways we can do this. Because we solved our inequality for y, taking care to flip our inequality, we can use the inequality symbol. So greater than or equal to, you can think of it as above the line. You can also test a point. So a lot of times we'll go ahead and just use the point 0, 0 as our test point. I usually just go back to the original inequality to plug it in. So 3 times 0 minus 2 times 0, is that less than or equal to 6? So we have 0 minus 0. We have 0 is less than or equal to 6, which is a true statement. So what that is telling us is the point 0, 0 is on the side of the line that has the shading. So as we come to take a look at our line, we said either above the line or the side that has 0, 0. So we can now start to see that this is where the solution set must be. But that's just for the first inequality. So now we want to come back and do the same thing with our second inequality, put it on the same graph. So I'm going to start with my y is greater than negative 1/4 x plus 5. This one's a little bit easier because it's already got y on one side by itself. So this again is a line. This time the slope is a negative 1/4, so it's going to go down 1 and right 4. And it has a y-intercept at the point 0, 5 from our b value of positive 5. This time this inequality symbol is strictly greater than. It doesn't have the equals option. So we're going to do this as a dashed or a dotted line. So if we add this line to the same graph, I'm going to start at the point 0, 5 on my y-axis, and I'm going to go down 1 and right 4. So a negative slope should be decreasing as it moves from left to right across our graph. And then I'm going to connect my dots using a dotted or a dashed line. So you can see how this has split our graph up into 4 sections now. 2 of those sections are shaded, 2 of those are not. So what we want to figure out is, of those 2 shaded sections, which one of those is actually our solution set. So because this was a greater than symbol, you can again think about that our shading is going to be above the green line. You can also do a test point again. We can use that same 0, 0. If I plug in 0 is greater than negative 1/4 times 0 plus 5, So 0 is greater than 0 plus 5 is 5. So 0 greater than 5, this time we have a false statement. So this is telling us the shading should be on the side of the line where we don't have 0, 0. So 0, 0 is down below our line, so we want our shading to be up above our green line. So if we shade above our green line, what you notice is that each line shaded 2 sections on the graph. We are looking for the overlap of those shadings as our solution to this system. So you can do a couple of things. You could erase the shading in the parts where you don't want. You could label your solution region, so we could take out our shading and put it just in our final answer to say just this portion are the ordered pairs, the xy coordinates that will make both the first and the second inequality true. The other sections may make one true or the other, but this is the only part that makes both of them true. So this is our solution to the system of inequalities.